Assalamualaikum.
Waalaikumsalam. So, hari kita masuk chapter baru, closed system. First law. Sekejap. Tadi. Saya nak tu jam. Hari dia masuk dia bising. Dia off kan. So, very good morning. Assalamualaikum semua. Semua sihat lah. You all tak buka muka saya. Nanti tadi. So, slide nampak?
Apa nampak?
Nampak.
Nampak. Okay.
Nampak ada. Kelas lain dia synchronize ke macam saya? Ke dia tak synchronize? Dia belajar kat YouTube je. Ke kelas saya yang wajib tadi? Kelas lain semua belajar kat YouTube ke?
Tak, sama.
Ada kelas lah. Saya ingat saya seorang je. Right. Risau saya. Yang budak FTKE semuanya YouTubers. Right. So very good morning to everyone. So today we learn about the first law of thermodynamic, which is related to the closed system. Right. So today is chapter 3. So tak lama dah lagi tinggal lagi 3 minggu je. Lepas tu you all akan pergi meninggalkan saya. Menyambut panggilan ilahi. Awak ada balik kampung ataupun raya di Melaka. Right. Otherwise, you have to stay here. If you raya Melaka, you can come to my house. If not, then selamat balik kampung. Saya pun balik kampung. Right. Okay. So we have finished the first chapter, which is related to the concept, definition, and basic principle. And last 2 weeks, we are entering the chapter 2, which is the properties of pure substance. Okay, now today and onwards is all related to the first law. You guys will learn the only first law. The easier part is a closed system. The challenging part is open system. Okay. So remember that when we say it's a closed system, that means the mass remain the same. The volume may change, but the mass remain the same. So don't get confused when we say change in volume, because the most important part is what the mass doesn't change. So volume, why the volume change? Because from the solid state, so like water here, when we steam up, so you see the bubble up there. So the mass, if you close the system, is remain the same, but the volume of the liquids and the volume of, let's say, the vapor or gas is based on the portion of X. Okay, but the mass is remain the same. Only the change of the volume. Okay, so there's things that this a little bit confusing in the closed system part. Okay, but the rest are, and when we come to open system, I think you guys will be okay. But the problem is that the problem is complex. So it's a complex problem. Then it takes time to solve the problem, right? Okay. Right. So, and then we look into the energy balance relation with the system that have no mass flow across the boundary. Okay. So this is called as closed system. Okay, there will be no open system. Okay, for this chapter. Okay, there is no change into or mass coming into the flow. So it's just a closed system, means like, let's say this kind of problem. So it's closed. Okay, so closed, that means only the volume can change, internal energy can change because you heat the system. The portion of the saturated liquid and the vapor can change, but the mass will remain constant. And if the heat is given to the system, that means the energy is exchanging. That's why I can feel it. My coffee is a little bit hot. Why? Because the energy is exchanging. So that's why by the time you feel that this water become very cool. Okay, atau just cooling process, is a quasi-static, is a very low process of cooling down. Okay, right. So only the energy can change, but the mass is remain the same because it is a closed system. So normally in closed system we have this so-called imaginary piston. Okay, so sometimes we call this is as imaginary piston, right? Although or it is a piston. Okay, kalau macam ni, this one is piston. If this one closed system, we call it imaginary piston. Okay, because it's closed, so it can be plastic, or closed set or whatever it is. But sometimes we call it imaginary piston. Okay, right. Then, so why do we call it work? Okay, so work normally relate to the amount of time. Okay, so work associated with moving boundary. So when it's either expand or compress. Okay, so you can either compress the work or you can expand the work. So let's say you're moving the piston down, so that means the gas is being compressed. If you give the heat to the system and the piston is moving up, that means you are doing work that is called as expansion process. Okay, right. So that's depend on the amount of your works that have been carried out based on the moving of piston. Let's say that we have the process known as quasi-equilibrium process. So quasi means a very slow process. Okay, so kini kita sebenarnya kita nak understand how the work is carried out. Okay, so now how do we calculate work? Work is what? Force times distance. So contohnya saya nak buka pintu tu, pintu rumah saya tu kan. So saya tarik. So we have pull the door up ataupun the door out. So I give a force. And then there is some angle of the deflection of the door. So that is distance. So that is S. Okay. So F ds is what? Is because force is what? Force is pressure times A or surface area. Okay, so that's mean F is what? So if you remember back, what is pressure? Pressure is based on the amount of force over area. So that's mean let's say I feel my head is a little bit shaky, so that's mean because of the force divided by the surface of the area of my head. So we change the position, so it's become pressure times this area is equivalent to force. So we got P. Okay, so P divided by A. Okay, P we got A. Okay, P A ds. So A ds is what? A is meter squared. S ds is what? Meter. So meter squared times meter is meter cube. So meter cube is what? Volume. So that's why P dV. Okay. Therefore, works is integration between 1 and 2, between work 1 into work 2, pressure time distance. Okay. Senang saja benda ni. So sebenarnya tak tunjukkan. So what we try to mention is that work is pressure times volume. How do we gain this formula? Is based on the integration process. Okay. Before that, you get that the work is what? Based on the force time distance, because the force is effect of pressure and area, so it's PADS, then it's become PdV. That's why work is equivalent to integration from state 1 to state 2 PdV. Engineering ini semua benda dia nak convert ke mathematics. That's why if remember that when we took the SPM exam, those who got A score, they sent to become medical student. Those who are second class, not that score in mathematics, ataupun yang kalau score gila-gila, dia akan hantar pergi overseas macam saya dulu, pergi study engineering. But dia yang smart-smart tu, dia hantar pergi medik. Sebab medik dia tak pakai pun matematik yang macam-macam ni kan. That's why smart people like me, kita akan pergi engineering lah. Kalau padahal kita takut darah. Kan? Cari tak sama medik. Kan? Kena cucuk vaksin pun takut. Tambah-tambah. Tengok darah. Operate kepala otak orang kan. So, okay. So that's why we learn engineering. So smart people like you all, like me, so we learn engineering. Kan? So because you want to convert everything based on formula. Right. Okay. So the process path is from 1 to 2. Kenapa ada integration? Integration means the process are not constant. So if the process are not constant, so they have a curve kind of process. So that's why the process path from 1 to 2 tu, they have a little bit moving down. Arela bulok. You kena ingatlah kalau arela bulok tu yang ke bawah, wirela bulok tu ke atas. Saya pun ada perkataan yang saya kadang-kadang saya tak boleh, bila saya cakap saya akan sebut. Kadang-kadang saya suruh student saya beli barang, dia kata, doktor cakap beli apa kan? Saya kata cakap Kedah, cakap Korea, cakap Dutch kan? Jadi English kan. Tapi bila suruh cakap Melayu, dia mesti lemah sikit kan? Kita cakap Kedah, cakap Melayu kan? Pak Arab cakap, apa benda untuk ni cakap? It's a joke, man. It's a reality and it's a joke. Okay. Right. So that's mean if change from V1 until V2. Okay. Normally the difference is between V2 minus V1. Normally we got the works in positive. So negative works means what? So negative work means the compression. Positive work means expansion. Itu saja beza. That's why kadang-kadang V2 minus V1 time P. So you got the value of works equals to negative, let's say 100 joule. That means negative means that the works are in compressed. Sebab kita menekan. So macam you all lah, saya pressure you all jawab exam. So I give you a negative work. That's why like D1 exam, you tengok sana, tengok kiri, tengok kanan, tengok kiri. Entah dapat apa pun tak tahu, tengok jawab exam tak betul pun. Kan? Right. And then A, the effect of area, A1 to A2, so P dV. So this slide is just to explain how that we gain the equation of works equals to P dV. That's it. So tak payahlah complicated. Nak faham macam ni, macam mana nak faham macam mana. It's a very simple process. It's PW equals to PdV. And so masa PS sebenarnya masa when we took the A level or when I took O level SPM lah, so British call it O level of Cambridge exam kan. So we have learned this formula. Okay, masa kita belajar physics. If you took pure maths, pure science class, then we have learned this formula already. Okay, right. So there are many types of process. One is known as the constant volume process. So when the constant volume process, that means there is no change of volume and there is change of pressure. So later on, when I teach you guys about, let's say I've just mentioned, so this process is known as the constant volume process. That means the volume does not change. The only change is what? The pressure. Okay. So that means, let's say we have two processes. So V2 equivalents to V1. So there will be no work. And so about P V2 minus V1. Can we find a work? Yes, because when we integrate 1 to 2, it's become ln V2 over V1. Right. So that's nanti kita akan tengok the example. And a constant volume process, constant pressure process, that means the pressure are the same. Okay, so let's say now I'm teaching you guys sitting on the table, on the desk, on the chair. So from 8 to 8:15. So let's start at 8 until 8:15. I don't feel pressure at all. Okay, so I just sit there here and you guys are listening while sleeping. And so the pressure remain the same, but the only difference is what? The volume. Why? Because while teaching you guys, I'm inserting more and more fluids into my body, which is known as a T. So T drinking process is known as the constant pressure process. So let's drink. dia cakap cheers. Cheers. Orang putih dia tak cakap thank you. So dia normally bila kita bagi bahasa, oh cheers mate, cheers mate. Dia cheers mate, dia mate, dia kawan, classmate, roommate kan. So cheers mate. Tapi kalau perempuan tak ada kata cheers. So kalau perempuan, kalau kat kampung saya dia kata thanks love. Tapi kat kampung saya dia tak sebut thank you, dia sebut ta. So kalau kat Lee sebut ta love. That's why student lelaki saya panggil baby. Student perempuan saya panggil sayang. Sebab memang dalam bahasa Inggeris we call it sayang. Sayang, sayang. So, jadi kalau perempuan panggil sayang, so menaikkan ni your classmate woman, your girls classmate call them sayang. So, thank you sayang. So it's because why? Because you are British. Right, and then we known as the constant pressure process. So constant temperature process is known as there is no effect of there is change both in pressure and volume. Okay, so that means we have work. But the work effect is that the temperature remain the same. There is no change in the temperature, but there is work, but they have both different kind of pressure and volume. So normally these kind of things, contoh macam saya kalau kita mengajar dalam kelas, so the pressure semakin meningkat lah after 1 hour, so the pressure will get be high, and the volume will also increase. So because normally I will drink a lot of water. Macam mana nak mengajar minggu depan? Jadi baiklah kelas you all pagi kan, so masih ada tenaga lagi kan, kalau petang jenuh saya. Right, so now we call it as a polytropic process. We have PVN, power of n equals to constant. So this one is almost similar to constant pressure process, but here the temperature also have some significant effect. Okay, and this is known as the PVN equals to C equals to constant when there is no change. Sebab PV equals to MRT, so there is no difference between the M mass, gas constant, and then also temperature. That's why we call it as polytropic process. Okay. So now, a rigid tank, for example, okay, contains 500 kilopascal, 150 degrees Celsius. As a result of heat transfer, okay. So now we have piston. Itu semua ya. Okay. So we give heat from 500 kilopascal, 150 degrees Celsius. The result of heat transfer, because we give Q here, so what happened? The temperature of the pressure and then drop to 65 and 400. So pressure drop to 400 and the temperature also drop to 65. Okay, but the volume doesn't change. So when the volume doesn't change, W equals to P D P, integration from the process 1 here to 2. So 1 to 2. So that means equivalence to no change of volume, 0. So what are the work done? So the work done are 0. Alamak. So jawapan dia kosong. Ha, ha, ha. Ambil kau. Okay. So what is the work? There is no work. It's a constant volume process. Okay. Very straightforward punya soalan. Tak ada dalam exam, tak ada lah soalan ni. Ini soalan celah gigi. Right? Okay. Now, a friction piston cylinder device contains 5 kg of steam at 400 kilopascal. So they contain steam. Right. Okay. Now, 200 degrees Celsius. Heat is not transferred to the steam until the temperature 250 degrees Celsius. If the piston is not attached to a shaft, so the mass of constant determine the work done. So there is change in volume and the pressure remain the same. So, saya tengok dalam muka saya, walaupun muka saya bukan handsome, nak tengok pun. Baiklah tengok kertas ni kan. Okay, so nampak nampak sayang?
Nampak.
Nampak So the volume remain the same. So tak allocate lagi lah. So WB equals to 1 process 1 to 2 P dV. So because P is constant, so P, so tinggal dV. Okay, so then from 1 to 2, because the front is 1, so what? So it become, kalau kita integrate, P delta V, kan? So P V2 minus V1. We don't know why it's V, but we know we can find it because it is water. So we can use steam table. And so in order to use steam table, we only have small v. So V large equals to M V small. So that's mean P M. So V2 minus V1. MV2 minus MV1 because it's the same volume. That's why MV2 minus MV1. So I take it out M. So PMV2. So because in alphabet it's what? M, N, O, P. So the way they put M front. So M, P, V2 minus V1. Where the hell are we going to find V2 and V1? So we remember that when we learn TV diagram. Okay. So we have, okay, the pressure remain the same. So P equals to, in the question state, P equals to 0.4 mega Pascal. Why 0.4? The question say 400 kilopascal. So 500 is equal to 0.4 megapascal. Why? Because we have to convert into megapascal. But the tables only have megapascal. So P equals to 200 megapascal. So we got only 0.2. The temperature they give you what? 200 degrees Celsius. Okay, so at 0.4, what are the saturated temperature here? So 0.4, they look into table B. 0.4. So 0.4, 143.63. 143.63. The question say what? 400 kilopascal, 200 degrees Celsius. So 200 is above. So that means this become superheated. So bila superheated, we cannot look at this table. So we have to refer to the what? Make separated. So 0.4, 0.4 here. Tak nampak. 0.4, 200 is what? 0.5342. Okay. 0.5342. So P2 equals to 0.5342 meter cube per kilogram. Okay. Ni 0 ni V1 lah. Right. And then let's say that ayat kedua. So the second sentence, heat is now transferred until the temperature 250 degree Celsius. So 250 degrees. So it's still superheated. Okay, because the pressure they doesn't change, that there is change in pressure. So sampai dekat sini 0.2 is 250. So it's still superheated. So 0.4 this is V1, so 0.4, V2 250 degrees Celsius, 0.5951 meter cube per kilogram. Now we can solve this problem. So M is what? The question give you 5 kilogram of steam. So jangan steam lah 5. P is what? 0.4. That's the question because the pressure remain the same. That's why kita boleh pakai one pressure only. And then V2 minus V1. So 0.5951 minus 0.5342. So 0.5941 minus 0.5342 times 0.4 times 5. So equivalence to 122 kilojoule. Okay, so we solve this problem. So masa you buat tutorial tu kan senang-senang kan macam ni kan. Sama lah. Masa when we do the first tutorial it's like this. So T1 P apa ni V state and then X. Because this operator tak ada. So state 1 ayat pertama, so the pressure are 0.4. Ayat kedua pun say that there is no change in pressure, so that's mean the pressure. Okay, the temperature we don't know yet, but we only know that the first is known as state of, sebab kita locate tadi we known as superator. Okay, that's why we can find V. Okay, and then temperature boleh dapat kan? Boleh temperature dapat because soalan give you at 0.4 200, 0.4 250 degree Celsius. That's why we can find V, and then kita tahu dia superated juga. Superated tak pakai X, then we can find V2. Dulu dalam bentuk table, before this in the tabulated form of table, but now it's in term of sentence. So the sentence 1 is state 1, sentence 2 is a state 2. Okay, sama saja sebenarnya, sebab you all kan engineer, so they must give you a question in term of sentences. Right. Kalau bagi table lah senang kan. Okay. So that is 3.2. Okay, now. And then kita tak nak bagi contoh banyak-banyak lah. Satu lagi last kot. Lepas tu saya kan bagi banyak lagi menangis pula bagi-bagi. The rest you boleh tengok YouTube lah untuk solve this tutorial. Right. And then the work piston. So one more question. So a piston cylinder bus contains 0.4 meter cube of air. Okay. Ni soalan dia bagi apa? Air. Air you cannot refer to steam table ataupun thermodynamic table. Tak ada. So bila kata perkataan air kalau soalan exam kalau oksigen, nitrogen. So untuk skop ni lah. Nanti kalau masuk, kalau you belajar lagi advance, thermodynamic yang lebih advance, then you gonna use, they have table, specific table. Tapi kalau untuk yang thermodynamic yang very low level ni, we assume that we give you gas constant, we give you everything. Okay, so you just use equation of PV equals to MRT. This one is referred to the ideal gas. Soalan yang berkaitan ideal gas, use PV equals to MRT. You cannot use steam table. So ada juga orang berjawab pakai steam table, tak boleh, because steam table is only for water. Australian sebut water. Tak disebut certification. Water. Right. And then, okay, so because this question is ideal gas, is an air inside a cylinder, so we have to solve it pakai PV equals to MRT. So, contain 0.4 meter cube. So the Stoichkon give you 0.4 meter cube. Okay. Right. So that is V1, and then V2. Okay. V2, they say that air is now compressed to 0.1 meter cube. So 0.1 meter cube. So state 1. Okay, state 1. So dia bagi V, and then dia bagi lagi apa? State 1. They give you also 100 kilopascal, T1 80 degree Celsius. Okay, and then V2 state 2. Tulisan buruk saya semakin my handwriting is getting worse after I have some surgery at my back. So my handwriting was so beautiful before, but now it's become like a real doctor hospital punya tulisan. Sedih kan lah. So that's a side effect of operation, right? Tulang belakang, right? And then V2 is they change it to 0.1 meter cube. and the temperature cylinder remain constant. So the temperature remain constant. So remain 80 degrees. So this is a constant temperature process. That's why we're going to be for 1 to 2 is. So 1 to 2 is as constant. The temperature is constant. So bila constant is as only from P process. Okay. So pada proses. So just remember a little bit of the regulation there. Okay. So we can use the same formula. W equal to 1 to 2 PV, and then PV equals to MIT now become constant. So 1 to 2 C over PV. Right. So then from there, C constant, 1 T K multiplied by constant, PV equals to MIT, PV equals to C. So PV equals to C over PV. But since MIT is a mixture of temperatures, but TV but the constant is one that side is C. So we can remove what the C. Okay, PV equals to C, PV equals to C over PV. Replace this equation here. It's just a linear, that's why C over PV. C is constant here around population 1 to 2. So we got C non PV over V2 plus V2 over V1. Okay, C is what? C equals to PV, so put back V non V2 over V1. So because this is C is V1. So we got the formula. So P is what? P is 100, 0.4, then non V2 is what? 0.1 over 0.4. Use your calculator again, get of 55.5 kilojoule negative. So that's meaning this is component. So bila kita compress formula, that's when the business is the area is not compressed. You don't want to compress. Meaning when they say compress, you don't expect the answer that you can get is negative. So when you got this negative, this is correct. So when you try to answer the exam, you will be getting the correct. So if you find out that's why when you look, when you try to answer this question, you look left and right, because you must stress, you want to look behind. Okay? There is a effect of something going on is wrong with you. Okay? But when you don't make more, separating all like that, dia tengok masalah kawan tu dia silap pakai dia pakai stable. Stable kan? Jawapan yang betul dia salah dengan bang. Saya nak lagi cuma yang betul yang salah. Asyik baik manusia yang beriman. Jadi saya pandai dia faham. Jadi kita hal-hal daripada yang kosong. That's why don't trust then you have to be honest with yourself. Okay. So that's it. Then I talk about the process that uses. Okay. Sometimes when there is also change of temperature, also P2 minus P1. So this is more on the calculus. Okay, that's what is the calculus. The mathematics itself on the mathematics itself is more related to the calculus. Then you have to worry about it. So because the calculus is like the model just follow the process. Okay. So the higher the x is example, then we get the hydrogen more, we have sulfur problem, we have to get the so then the big PV non V2 minus over V1. So the base question is one process, this one PV non V minus over V1. If we say that the Beei is not static in successive was process so that's we have to use that definition. The definition is the same equation but completely from and for isothermal process using the left example. If not isothermal, let's say the change. The change isothermal change temperature. So we use on the right side of the equation. Okay. Yeah. So if the process has no effect of temperature, we use plus one. If there is effect of temperature, you use on the left side. Why? Because you use 2 minus T1. But on isothermal, constant temperature processes, we use W2 to PV, not EP over 1. You don't have to understand the integration of it. Just know what you should use. So that's a problem, right? And then, okay, now. This is the first law. Now, we have the total energy system. The open system is very complex. So what we call it, the energy system. So the total energy is energy in minus energy out. What does that mean by energy in? So this one. We have heat in and heat out. We have, let's say, the system working in the system up and down. And then you have energy exchange. So we have water inside or something they have heat, they have wood, but they're moving out. They also have energy out. That's why we have this core energy out. So that is total energy. What is this one of the resources? And energy cannot be created, nor destroyed. So you can create energy, but what do I create energy? But can shift energy, you can transform energy into the same from temperature to the kinetic energy, from thermal to kinetic energy. So from the thermal energy, you go to the kinetic energy. So the kinetic energy will take it out so that's total energy transfer. In other words, heat is Q, wood is W, energy is Q plus W plus energy plus E plus W plus equals to total E of the system. Total energy of universes. What is total energy of universes? Or total easy system? Easy system is zero. Sebab dia get section energy let's make Q plus W plus E equals to zero. Sama. Dia macam spark particle. So everything the human resource for living is what has spark particle. Spark particle is what total energy of the system. So everything has that. So the human being will so start the protein can come this problem. So that is protein. So you know protein banyak. And then W is three things. And then the system has three things. Q, W, E. So in other words, U plus kinetic potential energy on the right side. Clear. Very simple. Energy change, energy transfer. So the total energy change equals to total energy transfer. And if we realize anything, that's mean zero. When this is the balance equation. So when the balance equation is on the left side, it's also on the right side. So if I like go, that's mean zero. So they call it from 0 to 1. From something like that. So zero is what, man? Is when everything is you gemuk, you kurus apa semua, so it's from zero, right? So for closed system, okay, we only left with two. There is no effect of E mass in and E mass out. So Q in minus Q out plus W in minus W out sama dengan delta E. Delta E ni pula, there is no kinetic energy, there is no potential energy. Because let's just move this piston moving on and up and there is no change of everything. Then it's become Q minus W equals to delta U. So when we say that it's a closed system, the one that you should jot down is, tu dia dah benda ni, Q minus W sama dengan delta U. Ini saja yang akan ditest untuk you all punya closed system. Very easy. Yang susah dia apa? Nak dapatkan U2 dengan U1, U state 1 dengan U state 2. But the equation are very simple. Q minus W sama dengan delta U. Okay. Kenapa delta E tu tak kosong semua? Contoh macam saya sekarang. Saya tak bergerak apa semua. Kinetic energy tak ada. Potential energy tak ada. Saya pun tak duduk atas bukit. I just on the normal ground level. But I still have internal energy. If I don't have internal energy, saya dah mati tu kat sini. So internal energy is what? Internal energy is the internal energy that inside your body. So it's for water is what? Mass time. If the specific energy, mass time, specific internal energy times mass. Ataupun if you large, it means internal energy equivalent to heat times minus work. Okay, so that's only one equation that you're going to use for the closed system. Very simple. Kalau satu equation ni pun you tak boleh faham, itulah masalah thermodynamic. Sebenarnya soalan dia senang je, satu equation je. Tak tahulah puan, what is the name of the puan that yang in charge this? Saya dah lupa nama dia. Faiza. Ya, akan ajar you heat transfer.
Faiza.
Faiza. Faiza also like you are. I think he used to be my student. You all also will be my colleague as well. And you all also one day will become. Sebab dia penyerah subjek ni, she's my boss. Although in terms of seniority and hierarchy of the professorship and designation probably high, but when teaching in this module, so he's the leader, she's the leader, or she's the boss. So you all kan. Tapi kalau Zahir memang saya pangkal, dia masuk UTM, nampak borang Zahir, dia budak mana? Budak Johor, koyak-koyak bakar, buang tong sampah. Syarat dia pertama sebab nama dia sama. Second, why do I hate him? Because they have same name with me. Second is what? Kalau dia tak handsome. Kalau tak handsome, apa semua tak ada suspect, so kita pangkal. So that's mean Zahir is this. So iklan. Right. Alright. So ingat so jot down one equation, Q minus W equals to delta U. Right. Another word, Zahir is suck. Zahir suck. I hate Zahir. I hate you. Right. Now, you all boleh terima lagi ke soalan saya ni? Boleh satu example lagi 8:46
Boleh.
Awal lagi. Saya ingat dah pukul 10 dah. 9, okey. Boleh good. Tahan je lah internet tu. Siapa yang internet dah tak ada data tu, saya try to compare lah. Kalau kat kelas boleh kita buat 2 jam kan. Kalau kat sini kita buat 2 jam, ada orang macam-macam masalah ni. So kita kena adil to be fair to everybody. So we try to limitalization into apa? 1 hour and a half or 1 hour and 15 minutes, 1 hour and a half lah, tak boleh apa, everything cepat sangat habis. So we have a spring-loaded piston. Okay, so boleh nampak. Kalau tak nampak, beritahu. So we have spring-loaded system. Okay, so we have. So kita tak spring of the piston. Okay, now a spring-loaded suspension contain 1 kilogram of carbon dioxide. So inside here is a CO2. Right. So Korea panggil apa? So carbon dioxide. Panjangnya. Kita panggil senang carbon dioxide dia panggil isanhuatanso. Okay. So contain about 1 kilogram of carbon dioxide. Ciliang dia panggil mass, dia panggil apa? Mass 1.0 kilogram. So this one is called ciliang. Okay. And now, so the system is then heated from, so let's say now mass is what? 1 kilogram. Instead from 100, so state 1, so bila state 1 kita akan tulis lah, state 1, T1 equals to from 25 degrees Celsius at pressure P1 100 kilo. Kita tak ingat lah Dash cakap apa insan sana tu. Dash ni dia banyak ho. Dems Herren. So dia kata macam nak duda ya. Dia kata cakap dengan Honda je ayat liom sombong dia. Oh dia pun sama je ni kasar dia. So until 300 degrees Celsius P2 equals to, alamak, hari ni juga lah pen habis. Ni semua salah Zahir ni. 1000 kilo. Alamak, kita buang pen. Habis semua pen saya. Kita ada pen lah. You all tolong kirim pen kat saya. Okay, right. So, 300 kilo, 1000 kilo, Pascal. Right. So, reaching 300 degrees Celsius, 1000 kilo Pascal. Okay, calculate the heat transfer, the work produced. Okay, now, so it's a very straightforward question. So we can draw. Dia tak pastilah Puan Faizah buat soalan apa. Dia nak saya buat soalan, lepas tu saya lambat sikit, lepas tu dia merajuk. Biasalah perempuan merajuk. Tak tahulah dia stres saya lambat nak bagi soalan, so dia buat dah soalan lah. So, susah, you all salahkan dia, jangan salahkan saya. So 125 1000 kilopascal. Okay. So 100 1000. So P kilo. This one is V. We don't know V, but we know it's 100 to 1000. And we know that this is this effect of heating. So 100 to 100. So okay, now, so we know that when it is ideal gas, because it is isanhuatanso atau carbon dioxide, we can use PV equals to MRT. So V equals to MRT per P. So that's mean untuk V1 MRT1 per P1, untuk V2 MRT2 over P2. Normally they will give you what is R. R is gas constant. So for isonuatanso, so normally dalam question, the carbon for carbon dioxide, normally the question will give you dalam exam nanti 0.1889 kilojoule per kilogram dot. Remember this one? Kelvin. Kelvin sayang. Kelvin. Kelvin. Bukan Dominic. Kelvin. Dominic C. Degree Celsius. This one is Kelvin. And so M is what? Mass is 0.1. R 0.1889. T1 Kelvin. Bukan Dominic. Ni Dominic C. And so with the silent D. DJ. DJ ada DJ? 25 plus 273.
Ada, sir.
Ada. P1 100. Ada lah. Bagus lah. Silent D. Saya suka silent D. So 0.1.
Prof.
1 kilo eh? 1 kilo silap. 1 kilo eh. Nampak? Tak nampak apa sayang? Ya, yeah, baby. Kau lelaki kan? Baby apa baby? 1 kilo. Sorry ya. 1 kilo eh. Time 0.1889. T2 is what? 300 plus 273. Ada lagi tanya lah. Kenapa plus 273? Because this is Kelvin. This is not Dominic. So, over 1000. So we got this one 0.5629 meter cube, 0.1082 meter cube. So how can we calculate the work? So the work is sini saya so W ni kalau nak calculate work ni kita kena pakai calculus punya formula lah. Kan? Sebab is area under curve. Calculus. Calculus panggil apa? Lupa. Okay. So area under curve is what? So n half P1 plus P2 V2 minus V1. And so we know that n half V1 is 100 plus 1000 times so V2 is 0.1082 minus 0.5629. So we got minus 250.1 kilojoule. Okay. Kalau minus ni maksudnya apa? Work done by the system. Work leave the system. Okay. Kalau heat we give is positive, work leaving is positive. So if negative work, that means the work that move the piston up. Okay. So you can either maintain this or you nak tulis 250 pun boleh, tak ada masalah. You nak maintain this one pun okay, this one pun okay. This one means the work is leaving the system. Okay. Heat in is positive, heat out Q out is negative depan dia. So kalau work out you dapat positive. If you give work in, you can negative symbol. Okay. That's why kalau you work out pergi gym, that's you positive lah. Jangan dia macam Zahir malas. Zahir pemalas. Okay. And then okay, ingat equation Q minus W equals to delta U. Ingat equation ni tadi yang saya suruh jot down. So Q equals to W plus delta U. Because this one is kalau kata water, we just can get MU2 minus U1 directly from the table. Because this is ideal gas, so ideal gas U is MCV T2 minus T1. This formula je lah. Right?
Prof.
Jangan apa dia sayang?
Atas sikit.
Atas sikit.
Tak nampak.
Tak nampak. Bawah tak
Oh,
nampak.
Tak nampak sudah. Okay. So W is what? W is this one, minus 250 plus delta U. So because this is ideal gas, so kita use this one instead of this one. So we use this one. So M 1.0 CV. CV is constant. So the question will give CV R ini sebab dia ideal gas spesifik untuk isonuatanso. That's mean carbon dioksida. And then, so that's mean dia akan bagi dalam question. The question will give you. Don't worry. Senang ya, kalau soalan tu dia bagi hint, dia bagi R, dia bagi CV, that's mean you have to use this equation. Don't use this thermodynamic table. Okay? So that is the hint. Hint is 0.657. This is coming from the question. Normally saya akan tulis, patutnya saya tulis kat sini, saya tak tulis. And U2 minus U1, U2 minus U1 is equivalent to T2 minus T1. So T2 is what? 300 minus 25. Okay. Okay. So sebenarnya kita kena sampul dengan 273 minus 273. Tapi disebabkan 300 campur 275, 273 minus 25 plus 273. So 273 minus 273. That's why saya tulis 300 minus 25 Kelvin saja. Sepatutnya kalau you campur terus pun bagus juga. Tapi kan kalau kita tulis 300 plus 273 plus minus 25 plus 273. So maksudnya 273 dah minus 273. That's why saya tulis 300 minus 25 kat sini. So dia ada juga confuse nanti. Okay, so dapat minus pada ni so dapat 69.4 kilojoule. Bila jawapan dia positif, that means heat given to the system. That's why soalan dapat A. Calculate the heat transfer to the system. So jawapan mesti dalam positif. Calculate heat transfer to the system. That's why jawapan dia positif. The work produced by the system, because you transfer, the work is moving in the piston up. Bila work produce, work akan dapat jawapan dalam, sepatutnya dapat negatif, so dia akan jadi positif, tak ada masalah. Right.
So, unit ke kilojoule ke?
Unit kilojoule. Kenapa kilojoule? Sebab sini apa? Sini kilo pascal. So that's why jawapan dia kilo. Sini tak ada masalah, sini meter cube. So kilogram meter cube pascal per, akan jawapan kilojoule. Kalau you pergi convert megapascal, dan jawapannya akan jadi lain lah. Faham? That's why first chapter kita belajar apa? Units. Thermodynamics ni kalau unit silap semua. That's why kadang-kadang you tak dapat full mark. You didn't get the full mark because at the end of the question, let's say you dah dapat 8, bila masuk kat sini you silap masuk formula. You buat pada dalam megapascal, tapi tulis kat sini salah. So instead of 10, you got 8 out of 10 lah. Tapi kebanyakan memang daripada nombor 1 salah. Contoh senang apa? This is carbon dioxide, this is ideal gas, dia pakai table ni. Dia pakai thermodynamic table. Itulah memang salah. Nak bagi markah ke mana? Apa tak tahu. Kan? Markah kesian lah. Pencil mark 1. Tapi kalau Zahir, tak pergi langsung lah. Sebab nama dia Zahir, saya tak suka dia. Right. Tak adalah lagi pergi buat laporan lah. Dr. Zahir tak suka saya. Right. So yang ni tak payah lah kot. Yang ni kalau saya tunjuk tadi sampai pukul 11 tak habis. Tak apa, nanti saya tunjuk dalam kelas next week. Rabu petang boleh buat kelas sebab malam terawih. So kalau if you don't mind, saya boleh buat lepas terawih. Kalau you boleh, lagipun tak wajib kan buat lepas terawih, tak apa kan. Okay, hari Rabu. Tak ada suksis Siapa ada masuk suksis? Tak parah lah dia masuk suksis lah. Ada budak suksis tak? Tak ada budak suksis lah. So kalau tak ada budak suksis, then kita buat pukul 2 petang hari Rabu boleh You datang lah sebab tutorial tak wajib. You want to come, just join. So tolong ingatkan saya lah hari Rabu ni dalam pukul 12.30 hari kan mesej lah. Kau cakap, Doktor, bertanya ada kelas lah. Saya ada kelas. Kita kan ada lab, kita kan ada tutorial petang ni. Seminggu depan tak ada lab, ada tutorial. Dia senang saja kalau ada tutorial, tak ada lab, ada tutorial. Tak payahlah tanya lagi, akan ada tutorial lah. Alamak, sayang. Sayang, ku kau luka, ku kau sedar, tak apa kau sedar. Kena nyanyi. So, now we call as a specific heat. Okay, so specific is what? Let's say you want to heat the iron, right? And also heating the water. So heating the water from, let's say 1 kilo of water, you heat from 20 degrees Celsius to 30 degrees Celsius. So when you heat though, there must be some heating effect. So how many joules are involved? So from 20 degrees Celsius to 30 degrees Celsius of water is about 41.8 kilojoule. But for iron, to heat from 20 degrees Celsius to 30 degrees Celsius, because it's a solid rock, or kita panggil solid rock, that means the formation of the molecules are very solid, then it's become 4.5 kilojoule only of heat. Okay, so the work only 4.5. Okay, this storage capability, macam soalan yang kita buat tadi tu, that means what? That means we call it as in thermodynamics we call it as CP or CV. Specific heat based on pressure or volume. So in other words, the specific heat, the meaning is that the energy required to raise the temperature of a unit mass of a substance by 1 degree. By 1 degree. Okay. Right, and then untuk water, specific heat, CV dia 3.12 kilojoule per kilogram degree C. Okay, watch out. Kalau degree C, tak payah, macam tadi kita calculate kan, plus 273. So kalau dia bagi CP or CV degree C, tak payah plus 273. Bila PV equals to MRT, T tu tak payah plus 273. Tapi kalau dia bagi kilojoule per kilogram dot K, mesti plus 273. So, watch out yang tu. Itu je kadang-kadang menyebabkan you all salah. Macam tadi soalan, the first we calculate is what? We calculate volume. So bila we calculate volume, katalah saya bagi CP nanti ada dalam bentuk degree Celsius in T of kilojoule per kilogram dot K, you all tambah 273, salah jawapan. So the first step salah, so all is salah, so you become the salah boy. So when you become the salah boy, that means you are zero boy, you become Zahir. Zero, right? So sebab tu dia Kiyomi yang dia buat mata macam tu kan. Apa lah buat lawak macam tu, buat mata macam ni kan, tak tahu lah. Dan dulu kan kalau Korea, dia sarang yo dia buat macam tu kan, dia besar, baru nampak sarang tu besar kan. Sarang yo, sekarang dia buat cinta, sarang macam love. Let's sweet lah, alamak. Itu perempuan boleh lah buat macam ni kan. Lelaki kena macam ni, I love you macam ni. Lelaki depan ni kalau jumpa awak, oi balik lu, I love you. Janganlah, love you sayang. Alah, tak cukup lah you punya love tu is not that much. So you have to do like this. Biar orang tengok betapa sayangnya aku pada awak. Right. So, okay, that's how it is. So, the portion of CV is portion of enthalpy over temperature, and for the CP based on the internal energy over temperature. Okay, so that's are the things yang you kena ingat lah. So kalau CV tu apa? Based on enthalpy. Delta U CP based on internal energy over temperature. Tapi sebenarnya dalam exam kita bagi je CP, CV, but in order to understand what is specific heat constant pressure and specific heat at constant volume is depend on enthalpy, and another one depend on internal energy. Okay, so if the question is on give you CP, then use 5.19. If the question give you CV, use 3.12. But the equation will remain the same. M Cp delta V and M Cv T2 minus T1. delta T juga. Okay. So remember last part, kilojoule per kilogram dot K and kilojoule per kilogram dot degree C. Okay. So watch out this one. If K plus 270, without K, just the amount of degrees Celsius given to you, put it in question PV equals to MRT, you got the answer directly or simultaneously. So ingat dalam table kita ada huruf H. Okay, H kan. H is what? U plus PV. Okay, and then H also U plus RT. And then for ideal gas, so we either have du CVT dt or CV CPT dt. Ni just for your knowledge je lah. Okay, if for you to understand and to appreciate what is specific heat, what is enthalpy, what is internal energy. You guys must know how to use this kind of thing based on the complex problem that been given to you in the question. Okay, but kita ni engineering technologists. We are troubleshooter kan. So when they have problem, we troubleshoot. So we use the equation to troubleshoot. So you guys must know what is the equation that we use. Okay, so nak faham senang. So delta U U2 minus U1 normally if the problem is water, we can use directly this one, U2 minus U1, okay, ataupun H2 minus H1, enthalpy state 2 minus state 1. But if for certain problem, U2 minus U1 equals to CV T2 minus T1, or H we use TP T2 minus T1. Okay, this one normally is for ideal gas. Okay, and this one on for water. So yang water yang depan ni. Okay. But sometimes water also we can use C T2 minus T1 if the question give you C, the value of C. Satu lagi nak spot, kita nak guna H2 minus 1 ataupun CV T2 minus 1 is what? Tengok soalan tu. Kalau soalan tu dia bagi CP ataupun CV, tu kena, that's mean to calculate the enthalpy ataupun energy change ataupun delta H change tu, kita kena pakai this one. Okay. Tapi kalau you pakai steam table, kalau water, kalau you pakai yang ni, you're gonna get the same result, almost the same. Beza sikit-sikit ya titik perpuluhan. The decimal point will be different, a little bit different, but the rest are the same. Okay. Right. Saya nak ajar lebih-lebih pun takut nanti you all confused lagi. So for electrical student, that's mean enough for you guys to understand this kind of situation. And how did they get this CP? Because the exam, they give you the CP and they give you the CV. It's actually from the thermodynamics table when they do the integration, that they get the average. Okay, the average they give you in the question. Jadi soalan tu jawapan nilai CP and CV all they given to you. You guys tak payah cari dekat table. You guys boleh pakai steam table yang water tu pun dah kira enough lah. Later on kalau you move, let's say you work in wafer fab industry macam Siltera ataupun you kerja dekat Manjung ke, Manjung saya tak pastilah, Manjung dia pakai apa, cakul, pakai water tu ingat. Ataupun you kerja Tasik Kenyir ke, ataupun you kerja nuclear power plant ke Jepun ke, kan? Who knows, kan? You know that back to my time when we Petronas have a team at Formula 1 and dekat Jerman, masa tu dia say we have 4 Malaysian that they being employed and work in Zurich in Germany and in Switzerland. And so masa tu kita bangga, but we don't know that at that particular Swiss punya team, masa tu kita punya Petronas team tu, nama team apa saya lupa nama Formula 1. So dia memang ada employ budak-budak yang grad daripada budak Malaysian, graduate from Fachhochschule Jerman, semua tu kerja dengan team tu straight. Bagi saya yang tu lagi smart. Dia orang apply dekat Sauber Petronas, Sauber team kan. Sauber team tu apply directly and they become final element punya engineer, rather than yang 4 special ni from Petronas join there. Dia ada beza sikit lah, and this was selected by Petronas. So that part of the agreement, this one is from Dia employ by itself. Dan cakap Jermannya apa semua. Sama ada senang aku boleh sampai ke situ cerita. Jadi dia cerita water ni. So that means you guys probably later on some of you work at NASA, some of you work kat apa ni. That's why dalam you punya head you cannot say that after I graduated I want to work at kilang Infineon. Janganlah macam tu. Think globally sikit lah. Ramai dah student saya kadang saya transit dekat masa dulu nak balik UK nak balik Leeds balik transit dekat Dubai jumpa student saya tu kerja mana sekarang dia tahu kerja Arab Saudi jadi apa dia mula-mula tak mau cakap lepas tu dia cakap dia kerja apa tu bukan drilling dia bahagian NDT disaster testing so NDT ni kalau level 1 tu dia punya salary duit kita is about RM100,000 per month bukan RM100,000 per year tau per month RM100,000 gaji RM100,000 RM200,000 itu belum yang cari gali macam tu kan yang macam Petronas cari gali tu kan Explorer kan itu gaji mau 100,000 per month semua gaji dia pelan dolar kan you know what the question they ask doktor cukup gaji doktor kat Malaysia amboi hinanya gaji lecturer kan yalah gaji lecturer sikit kan dia orang gaji dalam US dollar $20,000 these are the sort of things yang ni kan yang you kena tune je ni you all tak berjaya kerja kat Malaysia gaji $1,000 then you dah frust dan jadi study lah rajin take the opportunity kan when the opportunity come to you grab it macam mana nak soft tu kita cerita lain kan jangan takut nak apply big company ke apa kan kalau you kerja Petronas mungkin satu hari nanti ada seorang student saya budak PSM saja you dekat mana saya dekat Mexico sekarang Mexico budak UTM grade 2.6 tu kerja dekat Mexico grade 2.6 je kan sebab lepas tu depan dia habis ni dia disambung master dekat tempat lain kat UTM and then dia masuk LMG sekarang dia successful kan ni you all tak berjaya betul join insurance bukan tak elok join insurance boleh join insurance tapi kalau semua join insurance jenuh kita nak beli insurance okay so that's it see you all next week so ni nampak tak ni bukan lucah lah ni nampak sebelah kiri ni my office is on second floor ni Khalil Rizal ni maksudnya ni dekat Belanda rumah ni sekolah saya so nampak ni adalah satu teknologi di mana you know that there is a breast cancer in women so dia buat projek benda macam ni pakai electronic system design so you all budak-budak elektronik masa esok kalau you buat PSM try to find something yang can help people contoh macam tulang belakang saya dia pakai RF injection so you bayangkan elektronik tu macam mana dia trigger tulang kita so dia based on the electric about 10 second dia bagi elektrik so you all kan budak elektrik 10 second sekarang saya dah boleh balik jalan sekarang setahun saya tak boleh pergi masjid elektrik tu buat apa kat tulang saya pun saya tak tahu these are the things yang kan banyak benda yang kita boleh buat so jangan demotivate when they say that gaji engineer RM1,200 RM1,500 target nak kerja overseas kan baru dah smart so lecturer pun ramai pension jadilah profesor ke apa kan jadilah profesor kat overseas kan so you are banyak peluang ni so you guys are still young okay? So pergi kerja kat Middle East ke Middle East banyak nak pakai pakai lecturer right so, you all ni dah hilang ke apa semuanya ya ada ingat dah mati ya
Ada.
ayah
Zahir
Zahir dah tidur apa
Ni saya.
dia bangun tidur waktu dia apply mesej orang apa dah
Dia merajuk.
merajuk ya Allah buruk lah orang Johor ni semua panggil buruk lah semua geng JDT ni kalah orang tak boleh Adrian Tanah Sunggang Adrian tak Akmal Zahar
Saya Zahar.
Ashraf Farhan
Saya, sir.
Azizi?
Saya, sir.
Silent D?
Saya, sir.
Dominic C? Dominic sayang.
Saya di sini.
Hadira?
Saya, Prof.
Hasif?
Ada.
Ismail?
Saya, sir.
Oh, macam nama